In this video, we will look at a few different coordinate systems. We start with the familiar Cartesian coordinates, which are x, y, and z. In these coordinates, the position vector, traditionally denoted by r vector, can be written as xi hat plus yj hat plus zk hat, where I, j, and k are the unit vectors. Pointing in the positive x, y, and z directions respectively. If we focus on just a plane, and we see that x and y are perpendicular to each other, so this is an orthogonal coordinate system, and lines of constant x and y we can see intersect each other at right angles. The infinitesimal change in the position vector is dxi hat plus dyj hat plus dzk hat. This might seem obvious, but notice that it was only this simple because I, j, and k are constants. That is, their direction and magnitude do not change. Usually we use a right-handed coordinate system. So once we know the directions of x and y, we know the direction of z. The cross-product rule for a right-handed coordinate system gives us I cross j equals k. So this tells us that x cross y equals z. And so that tells us that in this case z, the positive z-axis, is pointing out of the page, which I will denote by a circle with a dot. From dr we can find the velocity in Cartesian coordinates, which would be dr dt, which becomes dx dt I hat plus dy dt j hat plus dz dt k hat. But this is simply vx I hat plus vy j hat plus vz k hat. And of course, if we want, we can go further and get the acceleration. We can abbreviate these derivatives by using the dot notation, so that v vector becomes x dot I hat plus y dot j hat plus z dot k hat. And so a, the acceleration, becomes x double dot I hat plus y double dot j hat plus z double dot k hat. Again, notice that implicitly what we are saying is that I hat dot equals 0, j hat dot equals 0, k hat dot equals 0. Finally, we note that the infinitesimal area dA, let's say in the xy plane, can be gotten by dx times dy. In our picture, this corresponds to a little rectangle here of length dx and height dy. Now, this was because it was in the xy plane, in other words, at a constant value of z. Since z was constant, dz was 0, and we took the product of the other two components to get the area of this infinitesimal rectangle. If we are interested in calculating a flux of some kind, then the area element has a direction, and in fact what we have is dx I hat cross dy j hat is equal to dx dy k hat. Of course, there is an ambiguity here. we could have equally chosen the area element to point in the other direction, in the negative k-hat direction. For an open surface, there is no preference. Either direction perpendicular to the surface may be counted as the direction of the area vector. And finally, we can get a volume element by taking the product dx, dy, dz. Next, we move on to the polar coordinate system.